So here we are, the moment that you've been waiting for, putting it all together. So what I've covered in the past little while is finding the x-intercepts of a curve, specifically a rational function, finding the y-intercept, finding the vertical asymptotes and doing the tests, finding the horizontal asymptote and doing the tests, or if there's no horizontal asymptote, finding the oblique asymptote and doing a test. And if you reach back into your memory, you might remember that there may be holes, and we can find the x value of those holes. We also have done domain. We haven't covered range. So what I'm going to do is I'm going to cover this list in no particular order, meaning that I am likely going to find out the x values where there are holes pretty quickly, even though it's near the bottom of the list. So this is not in order, which is why this is not A, B, C, D, E, F, G. Instead, it is just star, 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 star. Just find them all. And then when we're done, we sketch the curve. So like I've said, these are all the clues, and we're going to have to put it together into a picture. So to maximize your marks, if that's what you're after, if that's how you're wired, you need all this information. The picture, just drawing a picture, just doing a sketch, just doing a graph, isn't worth very much at all. So in our first note for rational functions, the x and y-intercepts, I told you that I would tell you a way to avoid that conflict. The conflict between potentially finding an x-intercept and having it appear as a number you can't have in the domain. So the easiest way to do that is to take the equation, whatever it is, and factor it first. So I'm going to do that here. And I'm going to do it in the space that we've got right underneath. So the numerator is a simple trinomial. So I need two numbers that multiply to be 4, that at the same time can add or subtract to be -3. And in the denominator, it's a difference of squares. And right now, I can tell you that there are no holes, and I can check that off my list. I will, sometime in the next couple of problems, I will tell you how to figure out if there's holes and how to tell what the x value is. In fact, I will tell you how to find the y value as well. So this is rational variable expressions from grade 11, where you factor, and if there's similar brackets in the numerator and the denominator, you cancel them out, and that doesn't happen in this question, so we can just go on. So what I'm going to do, because I need it, I have the original equation right here. I need to also take a little picture of the factored version. Now I'm going to make it quite a bit smaller so I can drag it along as we go and look at the question. So this box of information is pretty darn important. I'm going to erase this one because it's not as important as having all the information. So I'm now going to find the x-intercepts. Maybe plural, maybe not. So a reminder of how to find that. And I'm going to do a little bit of color coding, but probably not a great job. I'm going to tell you that I'm finding the x-intercepts, tell you what I'm going to do to find it, and then pull it off. And I am going to use the factored version because hopefully somewhere in your brain you remember that we're going to have to factor anyhow. So I've pre-factored. And then what we did when it was just finding x and y-intercepts is we put a 1 down, and then I did the cross multiplying. So I crossed this way first. 1 times the numerator is the numerator equals 0 times the denominator is 0. I'm choosing to dig out the green pen And I now know that my x-intercepts are 4 and -1. Now they should not arrive in the domain, so we're done x-intercepts and we shouldn't expect any conflicts. So the next thing, oh, a reminder, no double roots, no points of inflection to worry about, because in my list there's a bunch of stuff about asymptotes. So the next thing I'm going to do is I'm going to find the y-intercept, and it is a bit of a benefit to using the original equation for the y-intercept, because it is the easiest version to plug x into. So that's what I'm going to do here. So 0 squared minus 3 times 0 minus 4 over 0 squared minus 4. 0 minus 0 minus 4 is -4. 0 minus 4 is -4. So the y-intercept ends up being 1. So we'll have to come back at some point to steal this information for the grid. So the next thing I'm going to do is actually the next thing in the list, and that is finding the vertical asymptotes, possibly plural. So done that, onto this. When we go on and do the horizontal or oblique, I'm going to flip to the next page, and that's also the same place that I'm going to put the graph/sketch and the domain. Right now I'm going to find the vertical asymptotes. I'm going to do that in this place. What color did I do them in? Blue. So unfortunately that's the same as the y-intercept, but the vertical asymptotes were found by taking the denominator and making it equal to 0. So I'm choosing to take the factored version rather than the original version because I'm going to have to factor anyhow. Dig out my green pen just to annoy some of you. And I'll end up with vertical asymptotes, 2 of them. One is x equals -2, and the other is x equals +2. And yes, I could have written x equals ±2. I have to have the x equals, so if you don't have it there, you've messed up and will lose marks. So now that I'm done the vertical asymptotes, it's time for the vertical asymptote test. Do you remember what it is? Because there is some logic to it if you think about it. So what we're trying to do is we're trying to figure out what's happening on the left and right of the vertical asymptotes. We're going to have to do each one separately. So the first one I'm going to do is -2, left and right. And because asymptotes are lines that your curve is getting really, really close to, we have to pick a number really, really close on the left and on the right to -2. So I'm going to pick -2.1 for the left and -1.9 for the right. And I'm going to do my little plus-minus deal, which means I get to use the factored version. So -2.1 in this bracket is -6.1. -2.1 in this bracket, which is being multiplied, is a negative value. -2.1 in this bracket is just slightly negative, and -2.1 in the final bracket, also being multiplied, all multiplying and dividing, is a negative. So you've got 4 negatives being multiplied and divided, and that results in a positive, so I get to scribble up. Then I do the same thing for -1.9. So -1.9 in this bracket is -5.9. -1.9 in this bracket is a negative value. -1.9 in this bracket is slightly positive, and -1.9 in this bracket is negative. So I've got 3 negatives, so these 2 cancel out and become a positive, which when you include another positive stays positive, but when you include a negative is negative, so it's down. And this one is an example of alternating. Now we get to do the exact same thing, only our test is with x equals 2. So if you were wondering way back why I said keep labeling what you're doing, keep labeling what you're doing, it's because we're doing a heck of a lot for every single one of these questions. On the left of 2 is 1.9, and on the right of 2 is 2.1. So be careful with your positives and negatives, especially when you're talking about negatives. So positive negative thing again with this. In my factored version, 1.9 in this bracket is negative, 1.9 in this bracket is positive, 1.9 in this bracket is positive, 1.9 in this bracket is slightly negative. These two negatives, because it's all multiplying and dividing, will become positive, so the whole thing is positive, which is up. And finally, again, not hard, quite annoying, 2.1 in the first bracket is negative, 2.1 in the second bracket is positive, 2.1 in the bottom first bracket is positive, and 2.1 in the bottom second bracket is slightly positive. And one negative in a slew of positives will give you a negative result, so that's down. And this is where I start to get a little bogged down. So this is where I take all this information and I start to put it on a graph immediately. So unfortunately, I'm going to have to bop back and forth in order. Actually, I'm not going to, because we in my note, I may put it on 2 pages. Here, I'm just going to keep it on 1. So I'm just going to move this out of the way for a second, and I realize it looks sort of in the way, but I'll move it in a sec. So here's my X and Y axis. Tip, when you're putting everything together, please make your picture as big as possible. I can see my X-intercepts right now, so I'm going to put 4 here, labeled. Oh, did you see what I did? 4 here, labeled. It's time to quit. -1 here, labeled. Y-intercept is 1 here, labeled. Vertical asymptote, one of them at -2, x equals -2, and one of them at x equals +2. Labeled. So I'm concentrating on this one right here, so I need left and right. So left is over here, right is over here, something I'm very bad at. On the left, we have an arrow up at the top. On the right, we have an arrow down, which goes at the bottom. With 2, on the left, we have an arrow up at the top, and even though I promised to move that out of the way, it's not. Right is down at the bottom. And now I never have to look at that information again, unless I see something glaringly wrong when I try to fit it all together. So I'm going to keep going. And I'm going to set this here, but I'm going to cover my horizontal asymptotes here. Can you tell why I said horizontal and not oblique? Can you tell why there's no oblique asymptote? It's because the top degree and the bottom degree are the same. If the top was higher, that is the place where you get no where you get an oblique asymptote and you get no horizontal asymptote. So right now I'm about to pull off the horizontal asymptote, and before you think I've forgotten, here's that crucial line that lets you pull off all the math you're going to pull off in the next little bit. For horizontal asymptote, for finding it, I choose to use the original because I don't want to have to FOIL it out. Your step is take each term and divide it by the highest power of x in the entire question, which is x to the 2. And because this is our first question of the day, I'm not going to skip any steps. I also shouldn't talk and write at the same time. Now, I know going into this question that y equals 1 is my horizontal asymptote, but that's because I've spent years doing this. If you can tell that that is the answer, you owe me this line and this line. If you screw up, I can't give you full marks for obvious reasons. So, when I clean up x squared over x squared, I get left with 1. When I clean up 3x over x squared, I'm left with a single x in the denominator. I can't clean up the third term on the top. In the denominator, this cancels out completely, and we're left with a 1, not a 0, and I can't clean up the second term in the denominator. But because I have written as x approaches positive, negative, infinity, this will result in a 0, this will result in a 0, and this will result in a 0. If you've forgotten why, go back and take a look at the horizontal asymptote note or the video. So 1 minus 0 minus 0 is 1. 1 minus 0 is 1. And the horizontal asymptote ends up being y equals 1. So now I can put on, if I choose, and remember you can add this stuff at the very end, halfway in between, I've got a horizontal asymptote through 1. Oh my gosh, I'm hitting my horizontal asymptote. Remember that that's allowed for horizontals, but not verticals. So it is running through this dot, and I said that that was okay as long as it's in the center region, as in not 0, 0, just somewhere in probably between 5 and negative 5. So I have to figure out where to put my arrows, so that requires a test. Do you remember the test for horizontal asymptotes? This is the hard part of this unit, is keeping everything straight. So the test is putting in negative 10 into the original or equivalent, and then also putting in, 10 and negative 10 into the original or its equivalent, minus the horizontal asymptote. So I'm going to do both, just to keep me awake maybe at 9:47 on a Sunday night. If I take negative 10 and put it into the original, it looks like this, but I have to subtract off the horizontal asymptote number, which is 1. So that's 100 plus 30 is 130, minus 4 is 126, and that's 100 minus 4 is 96. Minus 1. Now I can do this in my head because I know 126 divided by 96 is higher than 1, and a number higher than 1 subtract 1 is a positive, so we'll have above. And then, like I said, just to keep this fresh, I'm going to put 10 into the brackets, just for fun. And you can decide which you like best, because assuming everything is correct, we should get the same answer regardless of where we substitute. So that's 6 times 11 over 12 times 8 minus 1. So 66 over 96 minus 1. 66 over 96 is less than 1. Subtract 1 is a negative answer, so that's below. So remember, this is left, and I have to put an arrow above, and this is right, so I have to put an arrow below. So left, out on the edge, above, right, out on the edge, below. And you will get some marks, probably -1 if that's all you do. You put all your information on the picture and do no joining. But please start to take some, I don't know, educated guesses. Like if this is a little fenced in area, maybe they join. And if this is a little fenced in area, ignore the x-axis, then maybe they join. But make sure that you join through any information. And then the one thing that isn't logical, if you still subscribe to the fact that you're not really supposed to go through asymptotes, but the horizontal's okay, is you should be able to join these little arrows as long as you go through the dots, and this is your rational function. Now the last thing we can do is we can figure out the domain and the range. So I'm going to do that here. We already know the domain. We knew the domain way back at the same time as the vertical asymptote. So I'm just going to steal that. That's not going to change. So the domain is x can't equal plus or minus 2. Now I have to squeeze in the range. So the range, you're going to have to look at the picture, which is why we've waited to this time to figure out the range or to state it. You have to figure out if there's any y's you skip over. And a lot of people think, oh, well, y can't equal 1, because if it's the asymptotes in this direction, then it should be the asymptotes on the up and down. But that's not true. It should be y can't equal 1, but the thing is, this one actually goes right through 1, so your answer is that, oh, I did it with the button again. Bear with me. Y is every number on the face of the earth. So I'm going to show you a different way of doing this if it comes up in the next couple of questions. I'm going to take a little break and I'm going to set up the next couple of questions. Not much setup at all. So this question is exactly the same. The characteristics never change. This is what I'll be asking you, and it's very important to remember that. You don't need to memorize these things. They'll be in instructions, but there's no extra information other than this in any rational function at all. So here I've given you another rational function, and like I said with the first one, the easiest way to avoid not recognizing a conflict, which also saves you time, is to factor first. So I need two numbers that multiply to be 3, not much choice, that at the same time make -2. And in the denominator, it's a difference of squares, so we have that. And this is a good thing. These two brackets are the same, one top, one bottom, in which case we don't have to look at them anymore. We can cross them out, and we have a much simpler rational function to look at. The thing is, This should remind you of rational variable expressions from grade 11. You can't just cross stuff out and go on without it. You have to make a mention of it. So you have to imagine somewhere, especially if you don't want to write down the green line. You've got the x minus 3 bracket, which used to be on the bottom, which ends up like this. And after that comma, you have to make a little mention of it. So you have to say, well, it used to be there, so I have to kind of count it. But I don't really want to look at writing it down all the time, so you have to mention it this way. Now, what that does is it lets you tell me that there is a hole at x equals 3. So now we have that. It also means that when I go to do my work, I can do my work with that, or I can do my work with that. So I'm going to take a break, take a quick picture of this so I have something to drag along with me, and then I'll get rid of the boxes because we won't be coming back here. If you want, you can go on with the X-Intercepts and stuff like that in the meantime, but I'm taking a break for fixing. So I'm going to leave a little space underneath this whole information because I want to come back here closer to the end. I've got my little box of information that I can drag around, and I've still got the purple box around the original and the purple box around the newest version, the cleanest version. I never really want to use that factored version. I want to go straight to the factored and crossed out version, mostly because that will give me the least amount of work. So hopefully you can focus on that as I am about to start the X-Intercepts. So X-Intercepts, I'm letting y equal 0. I'm going to do it here because why would I use extra information if I don't need it? I already know that this is a whole. So 0 equals x plus 1, and this will save us a boatload of time. And crisscross. 1 times the numerator is the numerator equals 0 times the denominator is 0, and then I can solve, and there won't be any conflict because I got rid of the conflict right here. Next up, Y-intercept. Let x equal 0, and I know I said I wanted to go back to the original every time, but I can also go back to this clean version. So f at 0 is 0 plus 1 over 0 plus 3, which ends up being just 1 over 3. If you're uncomfortable with that, you could use 0.333. Not that it matters. It's just a label in the positive area on the y-axis. So next up, vertical asymptote. So with the vertical asymptotes, you take the denominator, in my case the newest denominator, the cleanest denominator, and I end up with one vertical asymptote. So instead of potentially 2 of them, which actually one of them is a conflict, you end up with one of them, so that means your tests are awesome because you actually only have a left side and right side rather than 2 left sides and right sides. But this asymptote has a negative value, so you have to be super careful in picking your close to the left and close to the right values. And then I'm going to put these 2 numbers into my little boxed area. So negative 3.1 plus 1 is negative. Negative 3.1 plus 3 is negative. 2 negatives makes a positive, so that's up on the left. Negative 2.9 in the top is negative. Negative 2.9 in the denominator is slightly positive. 1 negative means we have a negative result, and that's down. And this is where I make my grid, because I am overwhelmed with information and I never want to look at this stuff again. I will have to come back and look at the whole, because I add that in at the very end. Or I guess I subtract it out because that's what wholes are. So remember to make it reasonably large. And I have an X-intercept of -1. A Y-intercept of +1/3. A vertical asymptote of x equals -3. All of these things need labeling. Then my little red pen, on the left I'm heading up, on the right I'm heading down. And I'm done all that. I never have to look at it again, except the whole. I am now looking at that box of information, which I can just see up there. Let's pull it down a little bit. And I can tell by looking at this that once again, we have no oblique asymptote because the top is not a higher degree than the bottom. I have a horizontal asymptote, which for full marks forces me to put this line right here. Y equals highest degree of x is x, so I'm going to divide everything by it. And I'm going to take a shortcut this time. So I can do a little bit of mathematical imagining. I can imagine that when I clean this up, I will end up with an x on the bottom, mostly because I can't clean it up. Same deal here. X divided by x is 1. So we get 1 plus 0, which is 1, over, there it is again, 1 plus 0, which is 1. So I end up with that as my horizontal asymptote. So while my picture is visible, 1 is higher than 1/3. We'll need a label. And now I get to do my tests. So f at -10 minus the horizontal asymptote, and f at 10 minus the horizontal asymptote. I'm just going to group this together because I'm realizing right now that when I go to do domain, I don't want to do any scrolling, so I'm going to move this down a bit. And because I need it, I'm going to pull this down. And again, I'm going to use the bottom box of information to do my test because it's way less material, and I think I can successfully put in -10 and 10 in there easier than the top box of information. So -10 plus 1 over -10 plus 3 minus the horizontal asymptote, which is 1. So it's -9 over -7, which is actually a positive. More than 1 minus 1 is a positive result, so that's an above. And then 10 plus 1 over 10 plus 3 minus the horizontal asymptote, so 11 over 13 minus 1 is 0 point something minus 1, so negative and below. So above, below, above, below. See how handy it is to have this in the right order, as in left on the left and right on the right. So, time to join. Well, it makes sense that this little fenced-in area would connect. There's no dots to run through, but in here, let's see if I can do this. Not bad. And I have that. And you're not going to get full marks for that. And it's not because we missed the domain and range. It's because we have to go scan for holes. And we had a hole at x equals 3. See, it's up there in purple. So I'm going to come back down here, and I'm going to find me a place where I want to say x is equal to 3, and then I go up to the picture and I draw a hole. Now if you want to, you can erase a little bit and then put in the hole. I don't expect the erase because I expect to see that little donut very clearly. So we're done except for domain and range. Let's look at domain first, which should be the easiest because we already know what our vertical asymptote was. And in this question, the range is not everything. We do skip over values here. And the values we skip over, we definitely don't touch the horizontal asymptote. And we actually don't touch this. But I don't know what that value is. So if I ask you the range and all you've got is the x value of the hole, then you don't have a number to put in here. So, oh, my mistake. We skip over that x value. So this is where I go back to the purple. And if you want to know what if you need to know what the y value of your hole is, you can take this 3 and put it back in to the clean version of your rational. So that hole is actually at the spot (3, 2/3), which means I skip over 3 on the x and I skip over 2/3 on the y, and that's the range. So now we have a complete picture. And my handwriting is getting hideous. It's lucky there's only one more question for me tonight. A little bit better. And my moving around and changing things is a very good example of why you should use pencil, especially for rational functions in math class. So there we have it. And now I'm going to take this, which is our last question, scale this back, and start the question. So I'm going to need a little pause time for that. So if you're taking a look at the time compared to when I said I was taking a break, you might notice that a lot of time elapsed and all I had to do was make this smaller. And the reason for that is when I shifted, my Techno pen fell under my couch, so I had to reach under there. So I had to move the stool that I use for a desk, and then I found a bee under there and a leaf that fell from one of my plants, so I had to clean up. And here I am, all stretched out. Back to the math, though, in case you're not concerned about my life. This is one of my favorite questions. You'll see why in a minute. So, my tip was get all your factoring done first, because then you will avoid any crazy conflicts that hopefully you don't overlook. This will take care of them ahead of time. So top, difference of squares. Bottom, not even factorable. I can wipe out this bracket with this, which means I have y equals x plus 5 remaining, but I have to account for the denominator number that I eliminated, so I have to tack that on. So I am going to cut and paste that. so I have something to drag along with me. And I will put it here and scale it back so it's not so gigantic. And let's start the question. And so far you might be thinking, this looks the same. Why does she like this so much? So, X-intercepts. My bad. Holes. I like to do it first. If there is one, you can tell there is one when you slash out a bracket and solve for that bracket. That's why when we did the first question, there were no holes, because when we factored, there were no brackets to slash out, so I couldn't do any solving. All right, back to my list. X-intercepts. Let y equal 0. So that's 0 equals x plus 5. I don't need to put it over 1 because I don't need to cross multiply. So negative 5 equals x. And just because I think that looks a bit weird, I'm going to flip it over and say that the x-intercept is negative 5. Next, Y-intercept. Very popular tonight. My friends are up late. Y-intercept, I'm going to use this. 0 plus 5. So the y-intercept is 5. Now we need to talk about asymptotes and tests. So asymptote number 1, vertical asymptote. Let the denominator equal 0. Hey, this is why this is my favorite. It's not even irrational anymore. This was irrational, this is irrational, but once I slash stuff out, it's not irrational. Rationals are letter fractions, so I don't have one. So I actually have no vertical asymptotes. And because it's not rational, I have no horizontal asymptotes. And because it's not rational, I have no oblique asymptotes. So, here's the highlight of the night. If you don't have asymptotes, you don't have tests. And that skips this and this and this. So we've taken care of x-intercepts here, y-intercept here, holes right off the top. So I can sketch this and then move on to domain and range. So I'm pretty excited right now, because what looked like possibly the same kind of question, maybe an awful question to your eyes, isn't. So I think everything's visible. X-intercept, negative 5. Y-intercept, positive 5. You should recognize y equals x plus 5 as y equals mx plus b. So just a little aside, This is a line. With a hole. And the hole, and remember this is a sketch, and the hole is at x equals 5, so I'm going to make x equals 5 here, which means my hole is here. And because I have smart word magic, I can do that. I am going to put arrows on the end of this. And do you remember how to find the y value for that? You take the x value of 5 and put it into what was left. So that's actually 10, which means this is 10. And now we can go on and do domain and range. So domain. Sideways. Do we hit all the x's? Yes, 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 yes. Hop over 5. Range. Do we hit all the y's? Start at the negatives. Yes, 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 yes. Hop over 10. Okay, so we are done this. So you have potentially questions that have no holes whatsoever, but lots of asymptotes. You have questions with holes and asymptotes, lots of asymptotes or a few asymptotes. Then you have questions that have holes and no asymptotes. You basically have every possibility under the sun, and your math should match your picture. So, if you go to the web page, you will find that I've got a bunch of extra examples, and I worked through all the work so that you can see all the solutions. Some of them are these, and there's a correction for page 43, 1 to 6, and its part C should be over x minus 2. If you need solutions, my advice is to go to those extra questions so that you have something to compare it to and work through it. So I'm calling her a night, and that's not bad for 3 questions. Anyways, I will talk to you soon, and hopefully there's no bees anywhere else in my house. Good night.